Hello again. This is Math 2232 coming to you from the College of DuPage, and the title of this lecture is A Numerical Integration, LSA, Low Stakes Assessment. As always, please be an attentive learner while watching this video. By way of introduction, as you know, Simpson's rule and the trapezoidal rule provide very powerful ways to approximate definite integrals. And as you also know, Excel is a powerful computational tool. So this LSA has you applying those notions to address a significant probability result from statistics. And the result will concern a probability density function shown here as f of x for the normal distribution, which you know the normal distribution is a bell-shaped curve like that. Turns out for the normal distribution, this bell-shaped curve is f of x is equal to 1 over the Greek letter sigma times the square root of 2 pi e raised to the exponent minus 1/2 x minus another Greek letter mu over sigma, and the whole x minus mu over sigma is squared. Now this is the probability density function for the normal distribution, and for any given normal distribution, sigma, that Greek letter, represents the standard deviation, a number, it is a constant, and also that mu, that Greek letter, represents the mean of that distribution. And so please observe and have in mind that for a given normal distribution, both mu and sigma are scaling and shifting factor constants up here, and that the probabilities are the area under the curve. So that's all the statistics you really need to know to do the problem, although you will be doing some calculus doing the problem. So what am I asking you to do? You're being asked to use both the trapezoidal and Simpson's rule to calculate accurate to 4 decimal places the area, which could be also known as the probability, within 1 standard deviation of the mean. Think about what that means, please, as you're doing the problem. And you're to show an Excel spreadsheet with your work, the calculations, and also in that Excel spreadsheet show your formulas. And certainly, as you know, a first consideration in determining this value of n is required in both your calculations. And so you want to show both your answers and the calculations that support this decision as well. What value of n do you need for the trapezoidal rule, and what value of n do you need for the Simpson's rule? And you should feel free to use the grace notes that are included in this video to assist you in your considerations and your calculations. And I'll show you the grace notes in just a minute. And as always, with LSAs, take-home protocols apply. That means you can get help in GSGs, you can come to my office hours, and you can also collaborate with your friends, but the work should be your own, but you can get help, including even the learning comments. Let's look at the grace notes. Okay, it turns out this is of interest to you, that the second derivative of e to the minus x squared over 2 is given by this, but even more importantly, the graph is shown here, and this number down here is -1. And you also may find yourself needing to know that the fourth derivative of that is e to the minus x squared over 2 times this fourth degree polynomial. But when you look at the graph, and that's even more important, you see that it goes like this, and that this number is 3. Both those things in the grace notes can be useful for you, and you should feel free to use those directly. In closing, now more than ever, time is precious. Each day must count. Do the math, it will make you strong. And now more than ever, take care of yourself, because self-care is important. And now more than ever, take care of each other, because we're all in this together. Strive to make a difference each and every day. Look forward to seeing you in class. God bless you all, and take care.